Hello, everyone. I'm so glad you're here. I'm Brooke West, Sustainability Communications Lead here at Emerson. I'd like to welcome you today to the first in a series of briefings on sustainability topics. Our objective for these briefings is to provide insight to the connection between how policy is shaping sustainability targets, how manufacturers are responding, and how technology is making it possible. Today, we're going to be focused on advancing renewable biofuels, and we have a lineup of 3 excellent speakers to take you through that. Marcelo Carugo is head of Global Refining and Chemical Programs. We're also honored to have Kenneth Lim, the director of the Singapore refinery for the Neste Corporation, and Julie Valentine, an Emerson expert in refining and sustainability management. These 3 subject matter experts will talk through the growth of the biofuels market, how companies are building their strategies, and the technologies being used to achieve their goals. A few logistics before we dive in. Please note that we are recording the session to share out with those who couldn't attend live. We will have a question and answer session at the end of the briefing, and you're invited to ask questions in the chat throughout the presentation. Your mics were automatically muted when you joined, so when it comes time for the Q&A, I will unmute you and then invite you to ask your question. Now I will turn it over to Marcelo.
Good morning, good afternoon, good evening. Thank you for joining us today in the first briefing on sustainability. I am Marcelo Carugo. I joined Emerson in 1998 and have more than 30 years of experience in the refining and chemical process industries, both domestically and internationally. I work with manufacturers globally to create a clear and actionable path to operational excellence using digital transformation. Today, we will talk about renewable fuels. Climate change, the Paris Accord, has brought sustainability forefront as a company strategy. Emerson developed a sustainability framework for a lower carbon future with the greening of Emerson, the greening by Emerson, and the greening with Emerson. On the greening of Emerson, we are working across 185 of our major sites to reduce greenhouse emissions, working with our energy providers, and embedding sustainability focus in our management process. The greening with Emerson is about engaging with external stakeholders to provide industry leadership, develop innovative solutions with universities and research centers, as well as to work to shape the future policies with regulators. And in the greening by Emerson, we support and enable customers' decarbonization with Emerson technology, solutions, and expertise in 4 pillars. Next. In these 4 pillars, decarbonization is the first one, and this is working with alternative energy sources. In emissions management, we are working on reduction of emissions, as well as carbon capture and utilization, for example. In electrification, we have heat pump technology, as well as energy supply optimization from production, storage, and distribution. And finally, in energy efficiency, we work with software technologies to implement and improve the efficiency at the plant level. Now, looking deeply into the decarbonization area, next, we find that the transportation sector is one of the largest sources for greenhouse emissions. For example, in the US, it's about 30%. And there are mainly 4 strategic directions to reduce greenhouse emissions in transportation. On the top of this chart, we see the ones that are related to vehicles, from mandates to increase fuel efficiency that range from 40 to 80 miles per gallon, depending on the geographies, to the mandates on zero-emission vehicles, from hybrid and fully electric vehicles. And in the bottom of the chart, the 2 are the reason we are here today. From renewable blending mandates, something that is not new in the industry, because, for example, the world has been blending ethanol for many decades into gasoline. And in the map, we can see in blue the countries that has these mandates in biofuels. In fact, there are more than 70 countries that have transportation fuel mandates, and we can see many more adopting them in the near future. And the second strategy is around low carbon fuel standards. And in recent years, we have seen many countries that are driving them. And we've seen we have seen much more development around renewable diesel and jet fuel. In the next slide, we see a bit more detail about that. What we see is that these mandates are generating, of course, demand for biofuels. On the left of this chart, what we can see is that for renewable diesel, companies are accelerating investment to increase supply. And so we see in the graph that, for example, by 2023, the forecasted supply of renewable diesel is expected to double from 2020. And this is happening with a healthy funnel of capital investments of more than 250 plants across the globe. And on the right, what we see is that even more recently, major airlines from America, from Europe, from Asia, have committed to driving to net zero emissions. And one of the strategies is the use of sustainable aviation fuel. We see many airline associations that are actually expecting to reduce emissions by 34% or more with the use of sustainable aviation fuel. A good example of this is the recent announcement that ExxonMobil will supply Neste sustainable aviation fuel for Singapore Airlines pilot project started in the third quarter of 2022. Now, how Emerson contributes in these projects next? We contribute both from the capital as well as from the operational perspective. Our Project Certainty initiative enables customers to eliminate cost, reduce complexity, and to accommodate late changes in capital projects, reducing, for example, total installed costs up to 40%, without having a project on impact schedule. That is really important as well, because in all these renewable projects, time to market is really of an essence. And we also have the born digital concept into the project. That is a incorporation of the latest technologies like digital transformation into the project from the get-going, allowing the plant to start performing a top quartile performance, for example, with the lowest energy consumption since day one, and maintaining that high performance through the lifetime of the plant. Now, how do you get there? How people does it? Well, now I will turn it over to Kenneth Lim from Neste, who will talk us about Neste transformation in sustainable fuels. Kenneth?
Thank you, Marcelo, and good evening, good day, wherever you may be in this part of the world. I'm Kenneth Lim. I'm the site director for Neste Singapore. And the refinery in Singapore has been running for about 11 years now, and I've been leading it for the last 6 years. For the next 8 to 10 minutes, I will briefly share with you Neste's transformation in sustainable fuels, how Neste's journey from a regional oil refinery in Finland to become the global leader and provider of sustainable and circular solutions in our common fight against climate change. So Neste was founded in 1948 as a state petrol company, primarily to secure oil supply for Finland. And over the next 20 years, it has expanded and built 2 refineries there. It has since then undergone several transformations. But the pivotal moment came in the late 1990s when a decision was taken to experiment, research, and invest in renewable diesel production. The first world-scale renewable diesel refinery was constructed in Singapore from 2008, and a year later, another similar capacity refinery was constructed in Rotterdam. Now, another pivotal moment came in 2018 when the board of directors made a decisive commitment for Neste to be a global leader in renewable and circular solutions. There was also a decision to expand Singapore refinery to double its existing capacity and also enable the production of sustainable aviation fuel. At 1.4 billion euros, it was the biggest investment in Neste's history. Now, I'll spend a few minutes to talk about Singapore expansion later in the presentation, but for now, let's continue our journey. And as I said, in 2018, we make another decisive commitment to be a global leader in renewables and circular solutions. And several new businesses were created and ambitious commitments declared, such as by 2030, to help our customers reduce their GHG emissions by up to 20 million tons annually, and to process more than 1 million tons of waste plastics annually. Now, to put that in context, in 2018, our renewable diesel production was only able to reduce 7.9 million tons of GHG emissions. So to reach 20 million tons by 2030 would mean that we will have to more than double our existing production capacity within 10 years. And we are also committed to reach carbon neutral production in all our global refineries by 2035. And that means we are committed also not just to reduce our carbon handprint, but also our footprint as well. So if you go to the next slide. So in 2020, about 94% of Neste's profits came from the renewable businesses. Now, this is a huge jump from where it was 3 years before, where less than 50% of profits came from the renewables. Now, today, we provide renewable road and marine transportation fuels, aviation, and polymers and chemicals. In road transportation, Neste is already a well-known established name in North America and Europe. And we are set for growth in the renewable aviation. Now, currently, Neste has a production capacity of 100,000 tons per year. And we have supply partnerships with the oil majors such as BP, Shell Aviation, and recently with ExxonMobil, who we have partnered, as Marcelo mentioned, to supply sustainable aviation fuel to Singapore Airlines for a 1-year pilot trial starting from July of this year. We have also partnered major airlines in Asia Pacific, Europe and Asia, and America and Europe. In APAC, we have partnerships with ANA as well as Malaysian Airlines. The renewable polymers and chemicals is a new business and growing business for us. And we have also partnered with leading companies in Europe, North America, and Asia Pacific. If we go on to the next slide, please. Now, our purpose in Neste is to create a healthier planet for future generations. And our vision is to lead the way towards a sustainable future together. Today, we are world number 1 producer of renewable diesel with an annual capacity of 3.2 million tons. You just heard the announcement by Neste just 2 days ago that we had a production joint venture with Marathon Petroleum. And we are expecting 1 million ton of renewable diesel production capacity increase by the end of next year. And also with the expansion of Singapore refinery, our total capacity by end of next year could reach 5.5 million tons. Today, our share of waste and residue is 92%, and we have emissions by the end of 2023 to reach 100%, which means we will be using the sustainable palm oil that we've been using for the last 10 years. Last year, our renewable products reduced 10.9 million tons of GHG emissions, which equals to a reduction or removal of 4.2 million passenger cars for a full year. If you go to the next slide, please. Now, the road ahead for us is not going to be easy. And we have a clear strategic roadmap going forward based on the 3 strategic pillars. Getting ready for the future, we continue to innovate and commercialize our new solutions. We will boost competitiveness and continue to transform our businesses. We continue to drive efficiency in operations and competitiveness through operational excellence. We will grow aggressively the renewable and circular solutions. The recently announced Marathon joint venture, production joint venture, is an example of how we intend to go faster and bolder in our fight against climate change. And we believe that executing these strategies well will deliver the business outcome that we need to drive sustainability, meet our climate commitments, as well as to create strong financial performance and growth for Neste. If you go to the next slide, please. Now, this is a picture of the Singapore expansion. Currently, our refinery in Singapore has 19 hectares, capacity of 1.3 million tons. When expansion is completed by first quarter of next year, the total area will be more than double the existing land area and have additional 1.3 million tons of renewable products, which includes renewable or sustainable aviation fuel. You go to the next slide, please. Now, we have ambitions to digitalize the Singapore refinery using advanced wireless technology to run our refineries safer, more efficiently, and productively. And Emerson has been our partner in our digitalization journey. And we have commissioned them in 2018 to set up the wireless infrastructure in our current running refinery. In the construction of the expanded refinery, we have also installed Emerson equipment and instrumentation with modern production and asset management capabilities ready to be deployed when the digital infrastructure of the whole expanded refinery is set up. Now, we believe there is so much we can do in the digital refinery. At this point, I'd like to hand you over to our host, who will share with you all the exciting possibilities of digitalization. Thank you.
Thank you, Kenneth. Great presentation. And thank you for sharing Neste vision for renewable, both fuels and plastics, and also your recent project. I think you have shown how Neste has embraced the transformation and utilizing in the new project certainty to enable the collaboration among offices from different countries, different continents. You have a modern production and asset management system, as well as the digital infrastructure for the future ready of your plant. Thank you very much. Now, Julie Valentine will show us some of the digital transformation applications. Julie, the floor is yours.
Thank you, Marcelo. Yes, hello, everyone. I am Julie Valentine. I'm the Director of Refining and Sustainability Solutions for the Measurement Group. I'm a chemical engineer. I've worked in the refining industry for my entire career, starting off with one of the major licensors, process licensors of refining technology. And then now I've worked for Emerson for many years, and my current focus is in all of the themes related to sustainability. Next slide. So let me start off talking about the digital transformation ecosystem. So this is our view of what that ecosystem looks like. So if you look at the left-hand side of the screen, you see that we start at the foundation with all the different components that would be in one of the plants. So that would include things like all the instrumentation, all the valves, all the analyzers. And on top of that, digital transformation can also be applied to assets, to things like heat exchangers and pumps. Above that, you have the process units and more complex assets. And then you also have above that, the plant environment where digital transformation, of course, applies. And then in those cases where you have multiple plants for a single corporation, digital transformation can be applied across many plants. On the right-hand side of the screen, you see all the different applications for digital transformation. So we're looking at device diagnostics at that foundational level, predictive field analytics, machinery and equipment health, embedded advanced process control, plant health and performance through optics, and all the way to the top, having simulation and digital twin technologies, artificial intelligence, and machine learning. So next slide. What we want to take a look at now is how does that apply to green diesel plants? So what we want to do is look at the challenges associated. These are the main challenges associated with a green diesel plant. And then the key enablers, the key digital enablers that allow us to improve our performance. So the first one I want to talk about is feedstock flexibility. This is a very important issue for the refining industry because they have to process so many different feedstocks, and requirements and regulations are changing so that they want to give themselves the ability to process any number of feedstocks. So there are two main things that I wanted to talk about. The first one is with regard to measurement technologies. So one of the challenges with measurement technologies is that the traditional level and flow measurement technologies, they depend on the properties, the physical properties of the fluids that they're measuring. And as I told you, feedstock flexibility is one of the key enablers or key challenges, I should say. And so we're processing all sorts of different feedstocks. We're processing everything from chicken fats to soybean oil to corn oil to forest residues. All these different sorts of fluids can be processed in these plants, and they all have different properties associated with them. So what we want to do is utilize level instrumentation and smart metering systems, for example, that are independent of these fluid properties so that you still get accurate measurement without any sort of compromise. So great examples are with Coriolis technology, which is mass flow technology. You can still very accurately measure, for example, loading of tanks, loading of rail cars. Also with tank measurement, of course, tank measurement, inventory measurements are also very critical. And utilizing radar technology is a great means of having measurements that are independent of the fluid properties. The other thing with using these smart technologies is that there are onboard diagnostics that help you to verify that these measurements are still accurate. What this allows you to do is to have accurate reporting of all the receipts, the shipments, the usage. All of these sorts of things are going to maintain their accuracy, and it's verified by you from the instruments themselves. The second thing that's very important and shouldn't be minimized is that this also increases operator safety. Having overfilling tanks, for example, can be a situation that where you not only is it bad for the environment, but can also impact operational safety. Same thing with overfilling tanks and rail cars. So utilizing technologies, understanding the principle of operation behind the instruments to know that they will perform to their, in the best way possible is very important. Next slide. Okay, this is another example of where feedstock flexibility went, a way to meet some of the challenges for feedstock flexibility, and that's in the reactor section of the plant. So as we're processing these different feedstocks, the reactions are going to be different. And this results, the heat of reaction inside the reactors is going to differ depending on what feedstock is being utilized. So having good reactor control is absolutely crucial to producing the desired diesel product. So what we can do with our analytics software is we can build models that enable us to identify the optimal and the suboptimal conditions during the non-optimal operating conditions for each different feed type, so that we are able to provide optimal targets depending on what type of blend we're using for the feedstocks, or when we have a feedstock change, making sure that it's seamless, that transition between different feedstocks is seamless, and we are optimizing the plants continuously depending on that feedstock. What does this mean to the operators? That means we can increase our diesel yield, we won't be overcracking, and it also means, again, improved operator safety because we'll keep those reactors within the operational limits. Next slide. Okay, the second challenge that I want to talk about is around equipment reliability. So there are two key digital enablers with regard to equipment reliability. One is asset monitoring, and by that I mean monitoring the assets such as, again, heat exchangers and pumps and compressors, and utilizing wireless technology primarily, also some wired technology, in order to continuously evaluate the performance of those assets. The second key digital enabler is corrosion monitoring, and I want to talk about that a little bit more in the next slide. So corrosion is one of the significant risks associated with green diesel feedstocks, and one of the things that we're really learning as we're processing more and more of these diesel feedstocks. So the first challenge is actually measuring the corrosion, and then the second part is utilizing that corrosion or utilizing the data or interpreting the data to know where corrosion is actually occurring so that we can take the mitigating steps to prevent it. So the technologies that we offer are on both sides of this. So first of all, how do we measure corrosion? Well, we have wireless ultrasonic sensors that enable you to measure the thickness of the metal in the pipes and also on the vessels in key areas where you know that corrosion could occur. And then the second part of it is software that allows you to take all of this data and to interpret it and visualize it to make it easy to know where corrosion may be occurring. And what does this mean for you? You get actionable information that you can then ensure that you're not having any corrosion in the plant or take the steps that are necessary to prevent it. So this means increased uptime of the plant, and it also means, in the worst case scenario, a reduction in loss of containment that could occur if the corrosion got to the point where you could have a breach in the vessel or the piping. Next slide. Okay, the third issue is regulatory and tax reporting. So in these green diesel plants, there is typically a lot of data that has to be supplied to regulators and government agencies. And so some of the digital enablers would be, first of all, a central data repository, so a place to host all of this data. And then the second is to be able to take that data and to have visualization and reporting of that data. Next slide. So reports, these renewable diesel plants have extensive reporting requirements in most countries. And so the sources of data, there are a lot of, the data is very extensive, first of all. So you need to collect data on everything from where the feedstock came from, how you transported the feedstock, when you're actually running the plant, how much hydrogen it's utilizing, how much energy, how much utilities are being consumed. All of this needs to be recorded. And the second issue is that there will be penalties or fines if there are any reporting errors that are found. And so it's important to have a platform in which all of this can be and really a way to automate all of this data gathering, the analysis of the data, the visualization of the data, and also these reports need to be flexible. The regulations for green diesel and all of biofuels are changing. There are going to be future requirements and future reporting requirements. And so it's important that these systems are also flexible. So reducing what this allows you, this platform for data management allows you to reduce the costs that are associated with this reporting. And it also gives you the ability to make sure that all of this data is auditable and the reports are auditable, a way to verify the accuracy of these reports. Next slide. Okay, and then the final thing, the final challenge that I've identified is around sustainability metrics. So what this means is things, for example, like continuous and predictive emissions monitoring, energy management, and carbon intensity tracking. So those are three examples of sustainability metrics, which are very, very important for these green diesel plants. Next slide. So the first example of this is around emissions, is an example of how we can use digital technologies to reduce emissions. So every plant has to have a way to depressurize the plant in the event of an emergency. And pressure relief devices are used for this purpose, where these devices will then be used to route the gases in the event of an emergency. It will route the gases to a flare system, and then in the flare system, they are burned and can be safely released to the atmosphere. So knowing what the source of those releases might be, the time, the duration, all of this is heavily regulated. And so having a way to easily note when, and record the time and the duration of the release is important. The second part of this, of course, is knowing exactly what was released. So having a compositional analysis is required for the emissions monitoring and also for efficient combustion in that flare. So what we have are utilizing wireless pressure gauges, acoustic transmitters, and also software that can interpret all of this data and be able to tell you exactly what the source was, where the release was occurring, the duration, and what was released. The other way of doing this and is using compositional analysis, using a gas chromatograph, for example, to know exactly what components went to the flare when it did release. So this advanced diagnostic information really eases the burden on operators in this emissions related field. And then the other thing is that a lot of times the pressure relief devices could leak. This is a known problem in plants. And so this software also helps to identify when pressure relief devices are actually leaking to the flare, so that can be prevented as well. So this really does address the specific problem of trying to reduce emissions in the plant and also helps to protect the environment. Next slide. Okay, this is a very important concept, which is carbon intensity. So most regulations and incentives involve monitoring the carbon intensity. So what is carbon intensity? So what this is a fuel's life cycle, or well-to-wheel greenhouse gas emissions per unit of transportation delivered. So in the graphic on the right, you're looking at the carbon intensity of a traditional fossil fuel-based transportation or production system for diesel fuel, where you're looking at the emissions from oil and gas production, from the transportation of that oil, to the refining of the oil, to that transportation from the refinery to the fuel pump, and then finally the emissions from the vehicle. So it includes everything from the generating of the feedstock to the refining of the feedstock to using of the fuel. And so for us with biofuels, it's important that we calculate or know and define exactly what the fuel's pathway is. So where did the fuel source come from? How is it generated? Is it corn? Is it chicken fat? Is it used cooking oil? And how did it get to the refinery? How did it get to the green diesel plant? And then how was it transported? And then what are the emissions from that green fuel itself? So all of this, the value of the fuel that's created depends on that carbon intensity. So what impacts that carbon intensity? What are the main things that impact the carbon intensity? First of all, it's the type of feedstock. And in the next slide, I'll show you some details of that. Secondly, and why the location of the green diesel plant is important, because the distance from the feedstock source to the processing of it also matters. And then the third thing, which we have as operators of a green diesel plant a lot of control over, is the processing energy efficiency, and emissions from the plant. So those are some of the things that really impact the carbon intensity. Next slide. Okay, so let's look at this a little bit more closely and see how can digital transformation impact the carbon intensity of the process. So as I mentioned before, the calculation of the carbon intensity depends on the feedstock. And you see on the chart on that left, the difference between the low carbon feedstock credit that you would get if you were to use used cooking oil, which is a very advantaged, it's encouraged to use used cooking oil because it's a waste product, versus, for example, soybean oil. So you see that the credit that you get is almost double using used cooking oil than it is using soybean oil. So this is very important. The second thing is minimizing the energy and the hydrogen usage also lowers the carbon intensity. And so there are artificial intelligence-based energy management systems that can really facilitate a plant understanding their energy usage and optimizing that energy usage. So when we have applied energy management information systems to plants, what we typically see is a reduction in the site energy usage by between 5 and 10%. And this will really significantly improve the carbon intensity score. Next slide. And now I would like to turn it back over to Marcelo to summarize what we have talked about.
Thank you very much, Julie. Great presentation. So in conclusion, today we have seen how renewable fuels and circular economy are key into the energy transition. Particularly, I would say renewable diesel and sustainable aviation fuel are more preponderant into this transition. We also seen how Emerson project certainty and operational certainty initiatives are critical enablers to the success of these projects, as well as the digital foundation is also so critical for the long-term success and competitiveness of these plants, exemplified by Neste. And finally, we also have seen several examples of Emerson's digital technologies to help achieve the sustainability goals and be more competitive in the market.
Thank you all so much for being here, and I look forward to working with you soon.